Hello world, my name is Shitij, this is the coding tree, and today we're talking about try-except statements. In previous programs that we've coded on this channel, we've kind of been assuming that everything will always go according to plan. For example, in programs where we've taken input, specifically when we've looked for, let's say, number input, we've assumed that the user would just give us a number. However, in real life, that's not always the case. Programmers have to constantly account for what users are going to do. Programmers have to ensure that they have enough walls built up so that users can't simply break the programs by inputting something that the program didn't really expect the user to input. Even in large companies, programmers have to ensure that users use their programs in the exact correct ways, and if users were to do something malicious, then the program is able to sustain itself past that. One way to do this in Python is to use try-except statements. Let's take the example of users inputting information that we don't want them to input. For example, here's a simple program in which we are simply taking a number, doubling it, and printing it back out. That's cool and all, that works. However, it's not exactly what we want the user to do. Why is that? Well, let me try inputting a number. If I input, let's say, 15, that works. The number is printed out, doubled, it prints out 30. But if I try to enter anything else, let's say instead of entering a number, I enter the word B, then the program just stops. It breaks because we're not ensuring that the user doesn't do what we expect him to do. We're not careful to check that the user inputs a word instead of a number. And sure, there are plenty of ways to do this that don't involve try-except statements. Like you can just check if the the variable x is equal to a string, or it's actually a number. However, that's not what we always want to do because there are several cases in which there's so many different possibilities that it could that checking all of them would be a hassle, and it's simply easier to use try-except statements. So that's why we need to use those in this situation to ensure that the user's input gets correctly handled. Using try-except statements is actually pretty simple. It's a lot like some stuff we've done in the past with if-else statements, except the if condition in this case turns into checking if there is an error in the first place. That's the keyword try. So here, in my program, all I have to do is write try at the top and then correct my indentation and put in the code that I had before into my try statement. So now I am checking, I'm trying to see if my code will produce an error. I am testing that code out, and if it produces an error, then I add the second statement, the except statement. That statement is going to execute only when the error is produced from the code inside of the try block. Pretty simple, right? Think of it like an if-else statement, except the conditionals revolve around whether or not code produces an error. And instead of erroring immediately and breaking the entire program, all the program does is run some other bit of code. So here, I am checking if that produces an error, and then in the except statement, I can simply write print, and then say something along the lines of, that's not a number, to let the user know what exactly we're looking for. So the user can't do that. However, what if something else in our code breaks? Let's say somehow something else is the problem that has nothing to do with the user's input. That's also something that try-except statements can address, because they can check if a particular type of error was produced. So in try-except statements, you can use these errors as keywords and check if that was the error that the try block actually produced. Here's a list of a lot of commonly used error keywords. Now, what type of error is this right here? Well, it's a value error because we're taking an input and casting it to something that it can't be cast in our first input statement. We're casting a string to an int when we really can't do that. So what I can simply do is write except value error. And that value error is going to, and that code in the except statement is only going to run when there's a particular value error. Then finally at the end, I can add a third except statement. Consider except statements with a particular type designated to be like else if statements or elif statements. These statements are simply to check an additional condition, and that's all except statements with a type designated really do. They check an additional condition and then run that code. Finally, the except statement works like just like an else. If the other two were false, then this runs. So within the context of our program, in the first statement, it's in the try statement, it's our normal code. In the except statement with the value error designated, we're simply going to write that's not a number because we know that the value error can only be caused by user input. And finally, at the bottom, we can simply write we are not sure what caused this error. Simple. So now let's test this program out. Here I can enter in a number, it'll double the number, that works. Next, I can enter any word I want. Let's say phone, and doubling that doesn't really work. That leads to an error, but we know that that's a value error. So we know that we have to run the second block of code, which is simply printing out that it's a value error. If all else fails, if we don't know what the error actually is, we can simply return the bottom statement and print that out. Which this will only happen if there's something wrong with the code in our program. So let's say I leave some error or typo in the first try block. That's not a value error, and finally that bottom line is the thing that runs. There's actually a problem with this program. This isn't really the type of user experience we want, because the user has to run the program again every single time an input fails. That's a problem. Because if a user inputs a word on accident or types in a letter on accident when they're trying to type in a number, simply they're going to have to run the entire program again instead of just the program allowing them to enter a number again. That's problematic because it's not the best solution for this problem, and it can lead to a bad user experience. So how do we do this? Well, you actually don't really need any new information that you already haven't learned to be able to execute this type of program. But I'm not going to give you the solution immediately. First, try to figure out how you can make it so there's an infinite loop until the user correctly inputs a number. Then the program ends. See if you can figure that out. Remember, you've probably already learned everything you need to know to be able to do this. And remember, this will likely involve a loop. All right, I'll let you figure that out, and good luck. I'll be back in a few seconds. Did you get it? Well, it's actually really not that bad. So first, we declare a variable which will be a boolean, and it'll simply be called run, and I'll set it to true for now. I'll do that all the way above the try statement so that it doesn't interfere with any of my other code. Then below that, I'll write a while statement. Remember, while loops will run while their condition is true and then stop as soon as it's false. So I'll write a while statement, and then I'll surround my entire TryExcept statement in the while loop. So it'll be inside of the while loop itself. I'll put that there, and then I'll simply put the condition of the while loop to be while run. So the while loop will run whenever the variable called run is true. Then at the bottom of my try statement, my very first try statement, which will execute when the user does it correctly, I'll simply set run to false. Then the program will realize that run is set to false, and it won't loop again, leading to us leaving the program and our program being finished. That's an elegant solution because it'll continuously run and it won't stop until the user gets the input right. even if the user inputs something wrong, like a word, it'll still run the program again and again and again until he gets it right. In software development, we can't always be sure about what the user is going to do. That's why statements like the TryExcept statements are so useful, as they allow us to ensure that our programs don't break. Hey everyone, that's all for now. If you enjoyed the video, make sure to leave a like, and if you want to continue your computer science journey with me, make sure to subscribe. Thanks for watching.